quadratic function, typically the pattern is going to go 1, 1, and then 2, 4. And the nice thing about a quadratic function is it has a line of symmetry right down the middle. So as long as you know those 3 points, you should be able to reflect the key points across the axis of symmetry. So this is going to be the x equals 0. We refer to it as the axis of symmetry. Now, I typically am not one of those teachers that say memorize it, but if you know that you're never going to just like know the pattern or know the numbers, these are the points that you have to memorize. You have to know these 5 key points in order to be able to graph a quadratic. We will still do like regular graphing with transformations and things like that, but today we're going to kind of focus on how to get this information from standard form and vertex form. So first thing, negative infinity to positive infinity on the domain, going from any lower x value to any upper x value. The range is going to be from 0 to positive infinity. Now, remember the reason why we use a bracket is because there is a point at 0, 0. So because there's a point there, that means there's a value that we are including. So we are including 0 into our range. And so it's going all the way up to positive infinity. Now, we have 2 types of concavity. It can either be concave up or it can be concave down. It's basically what direction is your parabola facing. And ours is facing upwards for the parent function. And we just said the axis of symmetry is x equals 0. Now, one thing I'm going to kind of add on to this that isn't necessarily there, the vertex of the parent function is 0, 0. So if this graph wasn't moved around any, like this is just y equals x squared, this is kind of the baseline of where everything is starting. So this is back in unit 1, what we tested you guys on. We tested, do you know how to identify these features from these parent functions? The only parent function in this entire unit is a quadratic. So it's kind of like self-contained. We're not going to ask you about cubics or cube roots or anything like that. It is quadratics only. So again, for my people who are new to the parent functions and transformations, this is the only one you have to worry about for now. Okay, so a little thing here. We have 3 technically forms that you can see a quadratic in. The most common one you're probably used to is standard form. So standard form allows us to kind of identify different features from the ax squared plus bx plus c. I will get the question of, do we get this table on the test? We do not give you this table on the test. This is information that you have to know. It is going to be things where you're doing it consistently enough that memorizing it isn't going to be the big issue. So first things first, we're going to kind of tackle this with information, and then we're going to kind of answer the questions for number 1 so we can kind of correlate these 2 things together. So when I go in and I look at number 1, it's already in standard form. What I like to do sometimes is I will go in and I'll identify what each of the values are. So I have A is -3, I have B is +12, and I have C is -7. That is coming directly from the equation. The only thing I will say, if it's not all on one side, move everything to one side. Combine like terms. Do the things that you would normally do if we were going to go in and factor this. Now, for the concavity, my A, it's negative. So is it going to be concave up or is it going to be concave down? Down. Okay. Now, I kind of swap, actually, the order I do these in. I actually like to find the vertex before I find the axis of symmetry. It doesn't really make a huge difference which one you find first. But that's personally what I like to do. So in order to find the vertex, and it kind of goes hand in hand with the axis of symmetry, we go in and we try to plug in negative b over 2a. So another way that you'll commonly see the vertex referred to as is h comma k. So in order to find h, I'm plugging in negative b over 2a. And the only reason I use h and k is because that's the way you're used to seeing it when it's a transformation. So I'm trying to tie that in so that it doesn't become like, well, it's h here, it's x there, we're just going to use hk. Now, in our problem, we have negative 12 over 2 times negative 3. And again, before you freak out and think, where's my calculator? We don't give you numbers that are going to be so insanely hard that you cannot do it by hand. So take it piece by piece. Don't freak yourself out. I'm going to go in and get negative 12 over negative 6. What happens when I have a negative over a negative? Positive. So this is going to end up being positive 2. So that tells me because the vertex is hk, the x value of my vertex is 2. And then I'm going to go in and I'm going to find k. Now this is the part where you will have to do a little bit more algebra than normal, but I'm going to come in and to find k, I'm going to take the original equation. So I'm taking negative 3x squared plus 12x minus 7, and everywhere there is an x, I'm going to plug in 2, because that's the x value that I currently have. So negative 3 squared, I'll scroll up in a second once I write it down, 12 times 2 minus 7. Now, again, don't like in your brain try to do this all and hold all the numbers in your head and simplify it. Take it piece by piece. The one thing I will point out, because I see this mistake very commonly on this test, is a lot of people will take that negative 3 and that 2 and they'll multiply those first and then they'll square. Why is that a problem? Do we want to distribute, or what's PEMDAS? What does P stand for? Parentheses. So you need to do your parentheses part first. So this is actually going to be negative 3 times 4 plus 24 minus 7. So that's going to be negative 12 plus 24 minus 7, which is going to give me 24 minus 12 is 12. What's 12 minus 7? 5. So the y value of my vertex is 5. And just to kind of highlight this so you can see it a little bit better, my 2 is coming from here, and we'll do green. My 5 is coming from here. So anytime you have standard form, you can use this to identify the vertex. Now, if you are like, what the heck is a vertex? Because I didn't really say specifically on the graph. Either the maximum or minimum, that is your vertex. In our case, if it's concave down, it's actually going to end up being a maximum. But if it's concave up, it would end up being a minimum. So now I have my vertex. The reason why I like to do that part first is when I go in to identify the axis of symmetry, all I'm really doing is trying to see what is h. And since we said the vertex has an x value of 2, the axis of symmetry is x equals 2. And a little note here, I'm going to put always a line. A lot of people will just write the number 2. And if that was written on a test, we could only give you half of the credit because it has to be the entire equation, not just the number 2, just as a grading aspect. Now, there are benefits to each method, standard form, vertex form. Standard form is really, really great when it comes to the y-intercept because the only thing you need to know for the y-intercept is the value c. So if it's 0, comma c, what's the c value of this standard form? What's the c from the equation? -7. So that tells me the y-intercept is -7. Now, it kind of flips. So for standard form, it's harder to find the vertex, easy to find the y-intercept. For vertex form, it flips. It's easy to find the vertex, harder to find the y-intercept. So you're doing about equal amounts of work. Now, just to kind of talk domain and range, sometimes I think it's helpful if you come in and kind of sketch what's actually happening with your graph. So I'm going to kind of draw a very rough sketch of this. So we know that it's going to be 2, 1, 2, 3, 4, 5, 2, 5. My vertex is at the top. And we said that this is going to be concave down. Truthfully, I don't really care where the other points are. I'm not going to look at your sketches and be like, oh, they didn't sketch this correctly, I'm going to take off points. As long as you know what the direction is, that's how we're going to find domain and range. Domain, just again, reminding, is our x values. Range is going to be our y values. So domain for quadratics that are concave up or concave down is always -infinity to +infinity. Now, in the event that you have flipped your parabola, it's now facing downward, it's no longer upward like the parent function, you're not going to write your domain or your range like we did up here, where we went from 0 to infinity. Instead, because those arrows go downward, they're going all the way down to -infinity, that is where you're going to start your range. And then the highest y value that you're going to take on is going to be +5. And because there is a point there, that means we are going to include it, and it's going to be a bracket. So there's two options in the case of ranges in the way it can be written. It can look like it is for the quadratic parent function, so number to +infinity, or it can look like this if it's concave down, -infinity to number. Those are really your only two options. You're not going to have a domain or range where you're using the union when it comes to quadratics. It is just going to be -infinity to number or number to +infinity. Any questions on standard form? Just a reminder, the one thing I would make sure that you highlight, you circle, you know, is, and it can come in either the axis or the vertex, you need to memorize this. X equals -b/2a. That is going to be the best thing you can know for standard form. Now, let's talk vertex form. This one is going to make a lot more sense to you because we've done this before. We have a quadratic function, and this is something where you can identify transformations. Let's start with some of the easy ones first. I'm going to kind of zoom in. If I have a +3, what is that telling me I'm doing? To the left 3. If I have a -6, what is that telling me? Down 6. Now, the front 1/2, it's a vertical something. What do we remember? Vertical compression or stretch? Compression means I'm going to squish it, which is what this fraction is going to do. It is a vertical compression of 1/2. Now, the stretches were any numbers that were bigger than 1. But the nice thing about this, and I'm going to kind of relate it to the formula that you have on the vertex form side, you should notice that in the writing of the equation, it has HK. And we just talked about where this graph is going to move. So immediately from our transformations, I should be able to come in and say the vertex, because of HK again, the vertex is going to be at -3, -6, because I've gone left 3 and I've gone down 6. That is why I said it kind of flips. The vertex is pretty easy to find from vertex form. it's harder to find in standard form. Now, my A is a positive 1/2. So is this concave up or is this concave down? Concave up. So if I had a negative, so if I were reflecting over the x-axis, meaning there was a negative sign at the very front, that would be concave down. One thing that stays consistent between the two things is the axis of symmetry is still h. So I'm going to go in and say x is equal to -3. Again, directly tied into the h of your vertex. And that's because when you draw that line of symmetry, it has to go through the middle point. It has to. So that is why it's always the same number. Now for the y-intercept, that's where it gets to be a little bit different. We have to do a couple of things. So we're going to go in, and in order to find the y-intercept, we have to plug in f of 0. So we have to take our entire function. So in our case, I'm going to just pull it from here so I don't have to scroll up and down. In our case, for f of 0, we are plugging in 1/2 0 plus 3 squared minus 6. And so we're going to do a little fraction review because fractions are not scary. They're totally fine. What's 0 plus 3? 3. And then the same idea that happened before, I'm going to do the parentheses first. Don't multiply the 3 times the 1/2 and then square. 3 squared is equal to 9. And so I have 1/2 of 9 minus 6. Now, don't be afraid of fractions. Remember, if you have a whole number, it's the same thing as it being that whole number over 1. And so I'm going to end up with 9/2 minus, what is another way, and I'm going to kind of color code this differently. What is another way to write 6 if I want it to have a denominator of 2? -12/2. So the reason why is because Liana took the denominator of 2 and multiplied it by 6, or -6. And that's how we got -12/2. So I'm just going to do -12/2. Anytime you want to take a whole number to a fraction, you just got to multiply it by the denominator. Not scary. You learned this long, long ago in 5th grade where you talked about first adding and subtracting fractions. But it's there in the back of your head. You were capable of doing it then. You are very capable of doing it now. So when you have the same denominator, a common mistake people make is they try to subtract or add the denominators together. The denominator does not change. The only thing you're actually going to work with is the numerators. 9 minus 12. What's 9 minus 12? -3. So my y-intercept is 0, -3/2. Now, on tests, we do not make you convert to a decimal. You can leave it as -3/2. If it was something like -6/4, we would want you to simplify your fraction, but again, you do not have to convert it to decimal form. Yes? You could also do that. But sometimes the fraction itself isn't easy, like 9/2. But the same thing would work for other denominators. Okay, so I've got my y-intercept, I've got my vertex. I'm going to go ahead and just use this space where I have the vertex written to kind of draw out what I'm looking at. I'm going 1, 2, 3, 1, 2, 3, 4, 5, 6, somewhere way down here. And this is going to be concave up because we said A was +1 or +1/2. Now, domain, again, if it's up or down, it's going to get left and right in just a second, which is why I keep saying up or down. It is going to go from -infinity to +infinity. So a classic parabola that we've graphed before, we spent a whole month graphing our values. It's going to go from -infinity to +infinity. What name is it? Okay, I'll look at it in a second. For the range. Since this is concave up, the lowest y value is going to be our k value, and that is going to be -6 all the way up to positive infinity. So we're going from -6 to positive infinity. Realistically, I would anticipate on your test on November 18th that you should expect to see at least some questions about standard form, some questions about vertex form. Most likely, we will never ever really ask you to graph in standard form, but we may ask you to still graph a transformations equation, kind of like what we've done in the past in Unit 1. So let's kind of switch gears a little bit, because there is one other way that we are going to look at parabolas. So let's go to the next page. This will not take us as long. Parabolas. They are a part of the conic family, basically meaning that there is a cylinder out there somewhere where if they cut it in a bunch of different shapes, it makes things like a parabola and a hyperbola and a circle and a cone and all of these weird things that used to be a part of the Algebra 2 curriculum. The last thing we keep is the parabola itself, because it's a quadratic, but there are a couple of different features with the parabola that come from knowing the conic part. So first thing, couple of things we already know. Axis of symmetry is the line right down the middle of our parabola. The focus is going to be a point inside the parabola. So focus is going to be here. And then you have something we call the directrix. And so I know it seems a little silly because we don't do all of the conics. If we did, it would make more sense. The reason why they have these different points is because there's different points within the cylinder where these shapes start to form. So these things are identifying features. The last thing that they kind of talk about is P, which is going to be the distance from the vertex. So this is my vertex on the center of my parabola. P is going to be the distance from the focus to the vertex and the vertex to the directrix. So this is P and this is P. They are equal distant. It's called equidistant, basically meaning they are the same distance above and the same distance below the vertex every single time. Well, not every single time, but for every single graph. The most important thing that you're going to take away from this is knowing what they are, because you just have to know what they're called because you're going to identify them. But the big thing to take and know and write, the focus is inside the parabola, and the directrix, I'm going to go outside, is outside the parabola. So anytime we graph these things, it's going to be upwards, downwards, left, or right. The focus is always inside the circle. It's always getting a hug from the parabola. The directrix is always outside, and it's always a line. Another thing I'm going to clarify, because sometimes we forget, the directrix can either be a horizontal line, and basically that means you're going to write y equals a number, or it can be a vertical line, which means you are writing x equals a number. Now, the nice thing about this is we don't really make you memorize much, other than the fact that the focus is inside, the directrix is outside, and how to write horizontal and vertical. What we give you on the test, and what we'll have for any of the tests, the semester exam, all of that stuff, is we go in and we give you this entire table. So the entire table that you see here, this whole thing, exactly as it is copied and pasted into the test. You don't have to memorize. We give this to you, and you can even make yourself a note. This is going to be on the test. I want to say in the formatives, we also have this pasted in, but I could be wrong. If it's not, I will paste it. There are a couple of different directions your parabolas can face. They can open upwards, they can open downwards, they can open to the right, and this is where you have to know your left from your right, or they can open to the left. Now, if you have to do your L and your R, or your L's and figure out which one's left, which one's right, do it, because you need to make sure you're picking the right direction. The formulas differ a little bit. Up and down pair together, left and right pair together. And so what I want you to notice is for the up and down, it's the X that's being squared. And for the left and right, it's the Y that's being squared. So that's how we kind of decipher first, like which one we're going to use. Now for you, having this entire table, bless you, on the very last column, it tells you it's opening to the right, it's opening to the left, and it tells you it's opening upwards and it's opening downwards. So you really don't have to think too hard, but if you want to kind of decide before you get to the question part, looking at x squared and y squared is your best bet. So let's try this out. I have given the graph, identify all key features, and write the equation of the parabola. So I'm going to scroll up because I have a copy of my table, so I'm just going to reference it here. What direction is this parabola opening? Downwards. So what I like to do, and this is just a piece of advice from your teacher who's taught this for a very long time, I like to go in and I like to look at the equation for downwards and I copy it next to where I need it to be. So I'm just going to write x minus h squared is equal to negative 4p y minus k. And this is coming directly from the table, and I'm only looking at the row that says it's opening downward. So I just wrote the equation that's there. There are three things that you need to write the equation. You need to be able to find h, k, and p. Everything else is going to stay the same. You're not plugging in for x, you're not plugging in for y. 4, you're going to actually multiply, but you're not doing anything. Those are the only three things you have to know. So the first thing, whenever you see the focus, and I'm going to kind of label some things that are already there. This point is going to be our focus. This line, and it's always going to be either horizontal or vertical. This line is going to be our directrix. And so the focus is always in line with the vertex. So even though it's not labeled, the vertex is going to be directly above the focus, or left of the focus, right of the focus, below the focus. It's in line with it. So when I go in to write the point, all I have to do is say 1, 3. Because that's where the vertex is. And it's always the point that's on the curve, not the horizontal line. Now, the nice thing about this is the vertex is still h, k. So I have two of the things that I need for my final equation. Going in and identifying some of the other stuff, it is 1, -2 is where the focus is. The directrix is going to be a horizontal line, and just to make a little reminder, horizontal lines are y equals, and you just want to see what is the y value that it's passing through, and ours is passing through 8. The axis of symmetry is a line that goes directly down the middle of the parabola, and in this case it is a vertical line, just to kind of point it out. And that is going to go through x is equal to 1. The hardest part about this, and not even that I think it's super hard because you're going to have the formulas, you just have to identify features. You have to be able to look at a graph and know how to write a coordinate point and know how to write an equation for a line. And that's really all we ask you to do. Yes, Christian? It'll always go through the focus and the vertex. So it should go through both points. Now, for domain, because this is up, down, it's going to go from -infinity to +infinity. The tricky part that people find on these where they're a little bit more complicated of a parabola is you're looking at the vertex as your range value. That's the only thing we're really focusing on still. So in the range, I'm going from negative infinity all the way up to my vertex, which stops at 3. So ignore everything else for domain and range. For domain and range, your focus is only this curve. That's the only thing we care about. Now, to write the equation, we have h, we have k. The only thing we're missing is p. And so all you have to do is either count from your directrix to your vertex or from your vertex to your focus. It does not matter which one you pick. What you'll notice is they should be the same distance. So 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So this means my p-value is 5. It should always be the same number because it's equidistant between both. So I'm going to go in knowing that p is equal to 5, and I'm going to simplify my equation. So I have, let's see, x minus 1 squared, and I'm just plugging into the formula that we have from the table, is equal to, what's negative 4 times 5? Negative 20. And then I'm going to have y minus k. And that is it. So the hard part of knowing what the values are from the formula is kind of taken away. You just have to be able to look, is it opening down, up, left, right, and decide from there. Do I have any questions so far? Okay, let's try one where we have to graph it. So let's do that first. This one is a little bit mixed up. If it's mixed up, biggest piece of advice I can give you, go in and put into form like the table. So the first thing I'm going to do, because the squared is on the right and I don't want to be on the right, I want it to be on the left. I want it to look exactly like what the table says. So the first thing I'm going to change is I'm going to move 1 over 16 y minus 4 squared to the left, and I'm going to put x plus 3 on the right, because all of the squared terms in the table are on the left. Now, the next thing, all of the squared terms are completely by themselves on the left-hand side, looking at my table of equations. So what I'm going to do is I'm going to come in and I'm going to multiply both sides by 16. So that is going to give me y minus 4 squared is equal to 16x plus 3, because 16 times 1 over 16 cancels each other out. So what I'm really going to be basing how I graph this on is this formula. So I would do, if I were you, because you will have, even on your test, we're probably going to make it so that the parabolas table is detachable or something. I would look at my table and I would look at my equation and I would try to match it as best as I can. The first thing I would pay attention to is what variable is being squared. In our case, it's the y. So that means it has to be left or it has to be right. The next thing I would look at is what sign does that 4p value have? It's a positive 16. So that means that this particular parabola is going to open to the right. It's kind of like process of elimination. You're looking at the value squared, and then you're looking at, is it positive or is it negative? And that tells you up, down, left, right. So let's go in. This one's pretty easy. It also may be helpful to you to go in and write the equation with no numbers plugged in. Again, just transferring this from my table. Vertex is always HK. So in this case, my vertex is going to be -3, +4. Because in the case of it being x plus 3, it's actually -3. So that's where the -3 is coming from. And sometimes you may want to go in and directly just plot that on your graph. -3, 4. Now, the really nice thing about these, we don't make you graph them like we do transformations. We said this opens to the right, so I'm just going to go in and I'm going to draw this as it's opening to the right. It doesn't have to be perfect. It just needs to open in the correct direction. So as long as it's opening in the correct direction, I'm going to say check. You get the point for it. Then you want to go in and you want to figure out the value of P. So in the place of 4P, we have 16, right? So if 4P was equal to 16, what does P have to be? 4. So one thing to kind of take away from that, the negative and the positive, that has nothing to do with the P number itself. That tells you what direction it's opening. So don't kind of tie that into what you're doing. So now for the focus, all I'm going to do is count 4 inside. So I'm going to go 1, 2, 3, 4. And where I end up is where I'm going to put my focus. 1, 2, 3, 4. And remember, it is always directly in line. So if it was up, down, it would be vertically in line. Right now, it's left, right. So it's horizontally in line with the vertex. The directrix, I'm going to do the same thing. So I counted 4 to get to the focus. I'm going to count 4, 1, 2, 3, 4, to get to the directrix. And this directrix is going to be a vertical line. And so my focus sits at 1, 4. My directrix sits at x equals -7. The axis of symmetry is always the line directly through the vertex and the focus. So in this case, that is y equals 4. And like I said, when you get to the point where you have most of this filled out, you're just identifying features. What is this point? What is this line? And that is it. So it looks harder than it actually is, or it should not be that hard. Okay, now here's where it gets a little tricky. Domain and range. Normally, when I tell you see a parabola, domain is -infinity to +infinity. This parabola has been tilted on its side. So instead, the range is from -infinity to +infinity, and the domain is starting at -3 and going to +infinity. Yes, Ite. Where did I get 4? It's from the equation. So from our equation form, whatever number is in the place of where 4P would be, that's the number that I use. It's just in line. So I went in and I counted 4 over. So from the vertex, 1, 2, 3, 4. And that's where I ended up. So 4 inside. The focus is always inside the parabola every single time. Always inside, always. It's like it's eating the focus. If I divide both sides by 4, what's 16 divided by 4? Yeah, you're welcome. Okay, last one. These are the 3 types of questions you could see, which is why we're covering them all so that we don't have to spend a separate day on this. Given the parabola, we have, again, I don't love when it doesn't look like, and the reason why we do this is because sometimes the district, when they write questions for you, they always like to flip these around. So we want to keep this here so we can show you, you can flip it back to what it looks like in the table. So I just rewrote it so that the squared number is on the left-hand side. Find the vertex and directrix. Use the graph if it helps you. This is a question, and on the test we will say, use the graph if it helps you, or you don't have to graph it, but you can use the graph to help you. You don't necessarily need to use the graph, I think it's helpful to use the graph. So the first thing I'm going to do is I'm going to match this up with the equation that it looks the most like. And in this case, it looks the most like a concave up because x is the one that's being squared, the 4p is positive. That makes things pretty easy. So I need to find two things and two things only. So I'm going to go in, I'm going to identify the vertex. Remember, that is just hk. So I have 3, 2. So that's my vertex. So I'm going to go ahead and plot it, 3, 2. Truthfully, it matters that it's going to open upward, but really I don't care about anything else other than the directrix because I only want to answer the question and then I want to move on. So the next thing that you need in order to find the directrix is going to be the value of p. So in our case, 20 is currently equal to 4p. So if I go in and I divide both sides by 4, that tells me that p has to be 5. So in order to find where the directrix is, remember it's always outside. So I'm going to go and I'm going to count 1, 2, 3, 4, 5. And this is going to be my line where the directrix ends up. It is horizontal, so it's going to be y equals, and you always want to look at the number that it passes through. So in our case, we would have the vertex is 3, 2, and the directrix is y equals -3. In problems like this, where we tell you we only want you to identify these two things, you don't have to do anything else. Literally, I found those two things. I'm not even going to do the focus or the axis of symmetry or anything like that. Only those two things. Yes.
How do you know where to go from the axis?
It's always outside.
Yes, why did you go left?
If it's upwards, it's always like it's always in line. So if I did it left, it would be something like this, which doesn't make sense. So it wouldn't be outside. So if it's upwards or downwards, here, we'll draw a quick picture. On your bottom of your paper, upwards, downwards, right, left. Focus is inside. Focus. Directrix is outside. So that could kind of show you the direction of where they should be. And then if you want to, vertex. It's always going to be the directrix is outside of the parabola. The focus is inside the parabola. Every single time. Okay, do I have any other questions? Okay,